Welcome to my classroom. The problem in this video comes from a conversation over the phone. This problem is good for Form 4 students after learning the topic of trigonometry. I am hungry, David said to Sarah over the phone. Sarah replied that she bought 3 slices from 3 different pieces of different size, and each of them was 1/6 of the whole pizza. She added, "You can choose either the biggest one or the smaller two." David was hungry and wanted to eat more. Suppose David could not see the pieces over the phone, and Sarah had no measuring instruments at hand. How should they solve the problem? Can you use your mathematics knowledge to solve the problem? Should David take the biggest one or the smaller two for his empty stomach? Pause the video and think about this. To eat more, it means that between the biggest one and the smaller two, David needs to decide which one is heavier. Assume the thickness and the density of the 3 pieces are the same. Then the problem is equivalent to compare the areas of the sectors. The area of a whole pizza is given by pi r squared, the area of a circle, where r is the radius. Therefore, the area of a slice of 1/6 of the whole pizza is given by pi over 6 times r squared. If we are given the radii of the 3 pieces, we can calculate directly and get the answer. Yet, the size of the pieces are not given, and we have no ways to get their values. However, to make the decision, we don't really need the exact values of the radii. We only need to do comparison. As the area of each sector goes with pi over 6, we can simply compare the square of the radii. Let A be the radius of the biggest pizza, B and C the radii of the smaller two. Then the problem is reduced to compare the values of A squared and B squared plus C squared. There are 3 possible cases for the comparison. First, they are equal. That is, A squared equals to B squared plus C squared. In this case, the area of the biggest one is equal to the sum of the areas of the smaller two. So, both choices give the same result. Next, they are not equal. Then, we have the second case. A squared is smaller. That means the area of the biggest one is smaller. So the choice is the smaller 2 pieces. Or the last case, A squared is bigger. Then in this case, the choice is to have the biggest piece. Now, the values of A, B, and C are not given. How can we know which of these 3 cases is true? David is good at mathematics. He asked Sarah to arrange the 3 slices so that their edges form a triangle, and tell him the type of triangle formed. With this answer, David can decide what to choose. If the triangle so formed is a right-angled triangle, according to Pythagoras' theorem, the relation of the sides of a right triangle is A squared equals to B squared plus C squared. That means both choices give the same area. So David can choose either the biggest one or the smaller two. If the triangle formed is an acute angle triangle, in particular, we consider the angle opposite to the biggest side and denote it by alpha. By cosine formula, A squared equals to B squared plus C squared minus 2bc times cosine alpha. And since alpha is acute, so cosine alpha is greater than 0. Therefore, we have A squared less than B squared plus C squared. That means the total area of the two smaller slides is larger. So David should take the smaller two. If the triangle formed is an obtuse angle triangle, that is, the angle alpha is greater than 90 degrees, then cosine alpha is less than 0. Together with the cosine formula, we have a squared is greater than b squared plus c squared. That means the area of the biggest slide is larger. Therefore, David should take the biggest one. The decision depends on the type of triangle formed. Yet, can the triangle always be formed? The answer is negative. According to the triangle inequality, the triangle can be formed when the larger side is less than the sum of the two other sides. That is, A is smaller than B plus C. So, when the larger side is equal to or greater than the sum of two other sides, that is, A equals to B plus C or A is greater than B plus C, no triangle can be formed. In this situation, what should David do? He should take the biggest one, right? I leave this part for you to explain. I hope you can see that your mathematics knowledge is useful for solving not only textbook questions, but also the daily life problems. I hope you find this little problem interesting too.